There is really no need to know how to code in C++ to run a Gen4-based Monte Carlo simulation, because some Gen4 programs allow you to import your detector geometry from pure text files. You also don't need to know how to compile Gen4 libraries or programs if you use the ones included in the container. However, if you are interested in turning your own Gen4 program into executable machine code, or simply curious about C++ and its mysterious compilation process, a little bit of C++ knowledge would be very helpful. In this video, we will take a practical look at compiling a simple C++ program across Windows, Mac, and Linux. This isn't just about following commands. It's about understanding what's happening under the hood. With this knowledge, you will gain a much better understanding of how Gen4 programs are compiled, moving beyond blind adherence to instructions. I have prepared a simple Hello World program written in C++ in my GitHub repository, Gen4. Its sole purpose is to print out Hello World on the screen. Unlike Python or other high-level languages, a C++ program like this cannot be run directly in a terminal. One must compile it first. That is, to use a compiler to translate it into an executable machine code. Most Linux distributions use GCC, the GNU compiler collection, for C and C++ compilation. It provides the G++ command to compile a C++ program. Clang is the C++ compiler for a Mac. It is GCC compatible. We can use the same G++ command in a Mac to compile a C++ program. If there's no problem in the compilation process, nothing will print out on the screen. We can use the V option to turn on verbose output that shows in detail the compilation process. For example, it is linked to the standard C++ library, and the result machine code is saved in a file called a.out by default. It is executable. We can run it directly in a terminal this way. The dot and the slash before the file name means the current directory. It is a quick way to tell the terminal where to find the executable. Hello World is printed on the screen. The program does what we want it to do. A.out is a meaningless name. We can use the O option to specify the name of the output file, such as hello, for example. The resulting file is identical to A.out and does exactly the same thing. It is too much typing and error-prone to type the whole compilation command by hand. We can save the whole command into a makefile, which looks like this. In addition to the compilation command, you can also add in the clean, install, and uninstall commands. Each block in this file is called a rule. We can use a simple make command to execute the compilation command defined in the first rule in the makefile. Make automatically check if hello already exists. If yes, it further compares its creation time with that of the source file hello.cc. If hello is newer than hello.cc, make will not compile it again. This is great because it can save us a lot of unnecessary compilation time. To force a recompilation, we can use make clean to remove the hello executable and type make again. This time, the compilation command is executed and the executable hello is regenerated. We can also call other rules defined in the makefile by their names, such as install, to install the executable hello into a system folder user local bin, where all commands are saved. However, as a normal user, we don't have permission to modify a system folder. We need to use the sudo command to run make install as an administrator to copy hello to the user local bin folder. We can then use the which command to verify that hello is indeed in the system folder user local bin. Now we can run it as all other command in the system without adding / in front of it. This is all very nice. However, it takes time to learn how to write a proper makefile. Worse, makefile is not a native Windows compilation tool. This is where another program called cmake comes into rescue. Using the same configuration file cmakelist.txt, cmake can create operating system specific compilation files, including makefiles for Linux and Mac, and project files for Visual Studio on Windows. cmakelist.txt is more human readable than the makefile. For example, we can add an executable hello for the source file hello.cc, and we can include hello as one of the targets for installation. In a Linux or Mac, if cmakelist.txt is in the same folder where the C++ source code hello.cc is located, we can use cmake-B build command to generate makefiles in the build folder, and use the make command to generate the hello executable in the build folder. In a Windows machine, cmake provides a graphic user interface for those of us who are not familiar with the command line operations. The same graphic interface is also available in a Linux or Mac machine. Personally, I prefer a terminal-based cmake interface, ccmake. It provides something similar to a cmake GUI, but in a terminal for us to fine-tune cmake parameters if needed. There is a cmakelist.txt file in the Geon4 source code, and also in each Geon4 example folder. Their usage is exactly the same as our simplest hello.cc example. That's pretty much all you need to know about compilation of C++ programs. To proceed to my tutorials on compiling Geon4 on Linux, Mac, and Windows.